Circling the red planet Mars are two tiny moons, Phobos and Deimos, each less than 15 miles across.
The really interesting thing about Phobos and Deimos to me is that I've always thought of them as kind of underdogs of the solar system in terms of the way all the other moons are. They might not immediately jump out as being places to look for water or life, but they do still have a very interesting story of their own to tell.
They're quite different from our moon in that they're very much smaller and are perhaps related to asteroids from the asteroid belt, but their origin isn't completely clear.
I first became interested in Phobos and Deimos really because they were so exciting and exotic and so different from what we have every day here on Earth. The discovery of the satellites of Mars occurred in 1877, which was a year when Mars was much closer to the Earth than it had been for some time. And an American astronomer, Asaph Hall, actually used a new telescope in Washington, the 26-inch refractor, and he found not just one satellite, but two.
The moons Asaph Hall discovered were just tiny pinpoints of light. It was to be another century before we learned anything about them.
Liftoff. Roger. 3 seconds. We're on our way. Roger.
Spacecraft first started to visit Mars in the 1960s, initially by flying by, and then in the 1970s the first orbiters went into orbit around Mars. In terms of Phobos and Deimos, they're always there for these Mars missions, and so they've often been kind of an add-on rather than the focus of a mission.
The first thing that was extraordinary about them, of course, is that they weren't round. All the other moons that we'd seen are round.
Small bodies don't have enough gravity to pull themselves into a spherical form, so Phobos is indeed, like most asteroids in fact, potato-shaped.
The very first close-up pictures of Phobos taken by the NASA Viking missions in 1976 were really quite spectacular. They showed the surface of Phobos to be covered with these parallel grooves right the way across it, and these were astounding. Nothing like this had ever been seen before. And they've remained really since that time one of the wonders of the solar system.
These strange grooves looked like they were coming out of the Stickney crater, which is the largest crater on Phobos. And at first it seemed likely that perhaps these grooves had something to do with that crater.
In 1988, the Russians decided to take a closer look with their spacecraft Phobos 1 and Phobos 2.
The highlight of the mission was going to be a low hovering phase over the surface of Phobos and the deployment of two landers, a stationary lander and a hopping lander.
But the Russians really weren't too lucky, and in fact Phobos 1 failed en route and Phobos 2 failed shortly before it was going to take all these fantastic close-up images of the surface.
That was really disappointing because I thought, well, we have a chance this time to photograph all of Phobos and to photograph it from very close up, because the ideas I'd been thinking of really required better imagery than we got from Viking.
It's really with the modern era of spacecraft with these really high resolution cameras that we're seeing incredibly beautiful and detailed pictures of these moons, and some of the images of Phobos are truly spectacular. We're seeing the giant Stickney crater close up in incredible detail, to the point that we can even see mini avalanches of material that has slumped down inside the crater walls, and they're just truly spectacular. Because Phobos is that bit closer to Mars, and because these missions are Mars exploration missions, it's just a function of that Phobos is the one that tends to be photographed in much more detail than Deimos.
Deimos is the kind of poor relation of Phobos and Deimos, I think. It's much smaller and it doesn't have those spectacular grooves. And the surface is also very much smoother and rather more rounded than Phobos.
Until we actually get a bit closer to Deimos, that part of the Phobos and Deimos story is going to have to wait for a later mission.
Better photography has also led John Murray at the Open University to develop an intriguing theory explaining the mysterious grooves of Phobos.
They didn't really look like fractures, which was the main ideas that people were proposing at the time. So then I started thinking, well, they must be impact craters from somewhere. And then it suddenly struck me, of course, it's very, very close to Mars. There are a lot of big impacts on Mars. A lot of debris is being thrown out all the time.
Bearing in mind Phobos is only 6,000 kilometres away from the surface of Mars, it's a very short distance indeed. So when Phobos is travelling in its orbit around Mars, it just happened to intersect this material.
Well, here we've got a picture of Phobos, and you can see that these grooves running across it, these two, for example, are completely parallel. They look almost as if they could have been ruled with a ruler. They're so straight. Now these, I believe, were formed by impacts of material into Phobos. And so this end of the groove would have been formed first, and as Phobos moves in this direction, so you get this string of impacts occurring on the surface, rather like a machine gun firing at a moving target.
Undaunted by their earlier failures, the Russians are now planning to go back to Phobos.
Phobos Grunt, this new mission from the Russians, is a fantastically ambitious and interesting mission. They're attempting to not just go back to Phobos, but take a sample from the surface and bring it back to Earth. This will be the first time that a sample has been returned from another body in the solar system since 1976.
Phobos Grunt means Phobos ground, and that's because it's a lander mission and will be sampling part of the ground of Phobos, that is the soil of Phobos. So it'll be something like the soil in my garden in terms of grain size, except that it won't have any plants or organisms in it. And that is actually called not soil, but regolith.
The Phobos Grunt mission is going to scoop up samples of this regolith and bring them back to Earth. So we'll be able to find out just exactly what Phobos is made of and how old this material is.
Of course, having a sample in the lab is fantastically useful. There's only so much information that you can get from in situ data, and people say that a picture is worth 1,000 words. Well, a sample is worth 1,000 pictures.
Phobos and Deimos are the only two other moons in the inner solar system, aside from Earth's own moon, of course. So in that respect, they're the next accessible moons to study, and perhaps understanding where they came from will help us to learn more about how the solar system itself was put together as a whole.